Hello everyone. This video will be on the 3.9 section of the IB/AA curriculum. Please pause the video for a second to look at the concepts, contents, and formulae for this section. One sentence that summarizes this section is reciprocal and inverse trigonometric ratios are used to investigate the trigonometry in a different viewpoint. First, let's look at the reciprocal ratios. We have known the sine, cosine, and tangent ratios for a while now, and these can be represented as SOHCAHTOA. So sine equals opposite over hypotenuse, and cosine theta equals adjacent over hypotenuse, and tangent theta equals opposite over adjacent. The reciprocal ratios are the reciprocals of each of these. So that becomes h over O, that becomes h over A, and that becomes A over O. And for each, the cosecant is the reciprocal of sine, so it's cosec theta equals h over O, and secant theta is h over A, and cotangent is A over O. You can see the definition of secant and cosecant in the formula booklet, so you can also infer what cotangent is as well. For me, the reciprocal ratios kind of feel like the alternate version of the existing ratios, something like the clone of Doctor Strange in the multiverses. Now, we can bring back the idea of the Pythagorean identity. It was sine squared plus cosine squared equals 1. We can massage this identity using the reciprocal ratios, and you can find them on the formula booklet as well. 1 plus tangent squared equals secant squared. 1 plus cotangent squared equals cosecant squared. And let's try a question that uses the Pythagorean identity with the reciprocal ratios. Given that secant theta is negative 2 over square root of 3, find tangent theta, where theta is between pi and 2 pi. Well, first, obviously, we're given secant theta, and then we want to find tangent theta, so I think we have to use the first version of the Pythagorean identity. Right? So let's do that. 1 plus tangent squared theta equals secant squared theta. Then let's substitute the value in. 1 plus tangent theta equals negative 2 over square root of 3 squared. It tells us that tangent squared theta is equal to 4 over 3 minus 1, and is 1 over 3. Therefore, tan theta comes plus minus 1 over root 3. At this point, we want to check, okay, what value is the right answer? Is it the positive 1 over root 3 or the negative 1 over root 3? So one way to check that is to draw our quadrants with the labels A, S, T, C. I think you've seen this before, where the first quadrant, A, stands for all. The sine, tangent, cosine are all positive. In the second quadrant, only the sine is positive, the tangent and cosine are negative, and same thing for the rest. Because secant theta is 1 over cosine theta, we can still use the labels. Okay, so secant theta should be the cosine. So that means if the cosine is negative or secant is negative, then it has to be somewhere over here, either the second quadrant or the third quadrant. Okay. Now let's look at the given range of theta, or the domain. The domain tells us that it's between pi and 2 pi. So that tells us that our answer is in the third quadrant or the fourth quadrant. And that tells us that our answer has to be in the third quadrant. The third quadrant is where the tangent theta is positive. So now we can you can get rid of the negative version. So we know that tangent theta is only positive 1/√3. The last part of the section is on the inverse functions. We know that the inverse trig functions are there to undo the trig functions. For example, if I have sine x equals y, then I can say that, okay, the arc sine of both sides, so x becomes arc sine of y. And we can do the same thing for cosine and then tangent. Let's see what the graph looks like first. So over here, let's plot sine x. Obviously, that's what the graph looks like. And then let's try to do the arc sine. Arc sine of x. Ooh, the graph looks kind of weird, right? So if we go back to the sine of x, the domain and ranges of sine of x is, the domain is all real numbers and the range is between -1 and 1. Okay, so that tells us that the domain of arc sine x, the one we were looking at right now, is -1 to 1, and the range is, well, here we need to be a bit careful. What is the minimum of this function? And I don't think we can do the minimum function on this graphing calculator to see that. So let's plot back the sine of x. And then we can see that if we find the minimum point from -2 pi to 0, the minimum point, that will be the corresponding the minimum value of our arc sine. But we know that this point, the local minimum, is -pi/2 over -1. Sorry, -pi/2 and -1. So if you change, because we're doing the inverse function, if you change the x and y, then we can conclude the x value of the minimum point of arc sine x has to be -pi/2. And similarly, the maximum will be pi/2. And therefore, we know the range of arc sine x is -pi/2 to +pi/2. And you can do the similar work with the arccos and arctan. The arctan shape is a bit weird, so let's quickly see what that looks like. So the graph that you're looking at right now is the tangent x, and the arctan has that shape over there. Okay. I hope you enjoyed this video, and try some questions in this section to really master the skills that we have learned. Anyways, I'll see you in the next video. Best wishes.